So this is shown as RNC. So RNC generally sits between the reader and then RFID middleware. So the RNC is an intermediate control layer between multiple RFID readers and then middleware or applications layer. So RNC is reader network controller. Okay. So why RNC is needed in the sense, for an large systems there may be dozens or hundreds of RFID readers is there. So sending all raw tag reads directly to middleware would cause high network traffic or duplicate reads and unnecessary processing load. So RNC solves this by managing the readers and delivering clean and aggregated and filtered tag events. Its functions is reader management, data filtering, aggregation, event processing, load balancing, interface with middlewares. These are all the main functions of RNC. First and foremost thing is it is a lightweight but secure protocol. So current EPC Gen 2 is more efficient but weak in security. So future protocol will balance low cost tag design with stronger authentication and then encryption. So it can be used hash based and some cryptographies and mutual authentications also. So it comes to and based on IoT, that is IoT integrated protocol, it merge RFID will merge with IoT frameworks. So it's directly cloud connectivity from readers, and it have some standard APIs and then seamless integration with the sensors plus RFID. Then comes to an context aware protocol. It works based on the location context, condition context and event driven messages. So these are all the handling process from context aware protocols. Then comes to an AI enhanced protocol. It is a major supportive and then adaptive anti-collision. Its system can adjust read parameters based on the number of tags interference conditions. So it ensures high accuracy in crowded tag environments. So I have to conclude the future of RFID protocols will move from basic identification to secure authentication, from stand-alone systems into IoT and cloud integrated systems. So from fixed standards, it's deliberate the flexible, adaptive and then AI driven protocols. So then maybe the next generation will likely be lightweight, secure, IoT ready, multi-technology and then energy efficient. The next one is vendor protocol in RFID. So in RFID systems, the vendor protocol refers to the proprietary communication protocol. It's developed by RFID equipment manufacturers, that is a vendor, to operate their RFID readers, tags and middleware. So before global standards like EPC Global and ISO protocols, each vendor created its own unique protocol for tag reader communication. Even today, vendor protocols still exist alongside standards for special features, optimization and compatibility with vendor specific products. So some key characteristics of vendor protocol, it includes the proprietary reader tag communication, reader host communication and performance optimized and then a limited interoperability. The proprietary, it's designed by specific manufacturers only. For example, Alien, Zebra, Impinj, like that. Then comes to an reader tag communication. It defines how a tag responds or how tag is read or written and anti-collisions methods. Then comes to an reader host communication. It's a protocol for reader to talk to middleware. Then come its performance is full and full optimized. So it often foster in some conditions than generic standards. These are all the generic standards. The host should again respond with and then make a request for an even list out. And if to form an HTTP response, it containing only the following that content. It indicates that an event has occurred. The reader makes a request. It's look like in blue line. So it is unlimited interoperability. A tag can read using one vendor protocol may not work with another vendor systems. So the functions of vendor protocol, it's for tag identification, anti-collision algorithm, reader controller, event reporting, and then error handling. For an example, I'm already told that is an alien Higgs protocol, impinge reader protocol, and zebra and NXP reader protocols. These are all the real-time examples of vendor protocols. So the next one is EPC Global Protocol Overview. So this one is developed by EPC Global, which it should be standardized how RFID is used in global supply chain. Its main goal is to ensure interoperability of RFID tags, readers, and enterprise systems across the industries and then countries. So all the core is the electronic product code, that is EPC. It is a unique identifier. It's stored on RFID tags. The EPC Global Protocol defines how tags, reads, and applications communicate using this EPC. So this is the layers of EPC Global Reader Protocol. It includes reader layer, MTB, messaging layer, and then transport layer. So the EPC Global Reader Protocol is often broken into layered functions. It's similar to OSI networking. So first one is reader layer. It is very closest to the RFID hardware, which means reader plus antenna. So manage tag population and RF operations. So that function is inventory of tags, which means either singulations and anti-collisions like that. Next function is executing the tag commands like read, write, kill, access like that. And third function is handling sections and memory banks and security. Then comes to a messaging layer. So this is before that the reader layer having the tag, it can be read by the read subsystem, then move on to event and then move on to output, and then it can be communicate if it's present to the host. So this is the reader layer. So the next one is message layer. It just defines the format and structure of the message exchanged between the reader and then host. It isn't standardized as LLRP messages. That means XML based or binary. The functions is encapsulation of tag report, reader configuration messages, event or notification messages. Next one is transport layer. It defines how messages are delivered reliably from reader to middleware host. Next one is transport layer. It defines how messages are delivered reliable from reader to middleware. So it works above TCP or IP or any other communication channel. Its function is reliable delivery for the message and maintain the section between the reader and then host, and it also handling the error, which means timeouts and then retransmissions. The final one is middleware. So it is an business logic layer, that is MTB layer. It's shown in block diagram. So it is an MTB layer. The EPC reader protocol is layered as a reader layer for controlling the tag operations, message layer for LLRP messages, transport layer for deliver over the network, and MTB for translates into the business events.